Welcome back. Today I'm going to be going over this geometry question that comes up on the SAT. Um, and of course, I don't want to waste any of your time, so let's get right into it. I encourage you to try this for yourself. Okay, assuming you're giving it a try, let's dive into it. So we have a convex polygon which has interior angles that form an arithmetic sequence. Okay, the smallest interior angle is 120 degrees, and each interior angle is 5 degrees greater than the previous one. Which choice is the number of sides of the polygon? So, a couple of key things to know here, right? We know that, well, first of all, these interior angles form an arithmetic sequence, right? And if you don't remember what the arithmetic sequence is, well, it's just a sequence that you add a specific number to it and it goes up, right? So for example, if you add 1, right, you add 2, you get 3, you add 2 again, you get 5, right, 7, 9, and so on, and so forth. That's an arithmetic sequence, right? There's a common difference, and that common difference stays the same, right? In this case, that common difference is 2. So in our problem, we're given that the first term, right, or like the first number of that sequence is 120, right? Because that's the smallest angle. So we have 120, right? That's the first one. I'm going to write A1 to signify that's the first. And we know that the difference is 5, right? Because it increases by 5 each time. So the difference, I'm going to write D equals 5. Now, to further progress on this problem, you need to know two things, all right? Two formulas. First thing you have to know is how do you find the sum of the interior angles in the polygon, right? So once again, the sum of the interior, right, angles of a polygon. The formula for that is pretty simple. It's 180 times n minus 2, where n represents the number of sides, right? Or the number of angles, right? Number of sides and angles are going to be the same. Now, that's the first thing you have to know, right? What you also have to know, right, is essentially the sum of an arithmetic sequence, right? And you'll see why in a moment, but just know that for a sum of an arithmetic sequence, right? Arithmetic, I'm just gonna write SEQ, right? The sum of an arithmetic sequence, that's n over 2, right? Where n is the number of terms in the sequence, right? Over 2 times the first term, right? Plus n minus 1 times d, which is the common difference. So once again, that's an important formula for this problem, right? The arithmetic sequence. What's the sum of an arithmetic sequence? It's that. So now, why are those even useful? Well, because what you'll realize actually is you can set those equal to each other, right? And that's going to give you the total number of sides. The reason is, well, if you find the sum of all the interior angles, right, of the polygon, we already had the formula for that, right? Well, you can just set that equal to the sum of the arithmetic sequence. The reason is because, well, the sum of the arithmetic sequence also gives you the sum of the interior angles, right? Because think about it, you're adding the values of the interior angles, right? You're adding 120, 120 plus 5, and so on and so forth, right? So that's why you can set those two equal to each other, because they both add up to the total sum of the interior angles. So now it's simple, right? What you do is set those equal to each other. You know A1 is 120, so let's kind of write that down. So you have n over 2, 2 times 120, right? Because that's A1, that's the first term, plus n minus 1. D, that's a common difference. In this case, our common difference is 5, right? Because each one is 5 greater. It changes by 5 every time. So you do 5 there. And that's our formula, right? and we're setting this equal, well, to this, right? This sum, the sum of the interior angles in general, which is 180 times n minus 2. You'll realize now that we only have one variable to solve, which is n, right? So now I'll just use decimals. So in this case, you have, I'm gonna use x instead of n here, right? It's the same logic. It's just it actually allows us to graph and see the intersections. So you have x over 2, 2 times 120 plus x minus 1 times 5. That's the first equation, and you said that equal to 180 times x minus 2. So once again, right, we're given those two, and you're trying to find the value of n, right? Remember, n represents the number of sides, right? So in this case here, right, that's the number of sides. And in this, of course, that here in the arithmetic sequence, n is the number of terms, but you got to realize that the number of terms is going to also be the number of sides, right? Because it represents uh, the amount of angles, amount of interior angles, right? So you set those equal, right? And if you see these two graphs on decimals, you'll see that they intersect uh, at two locations, right? 16, x equals 16 and x equals 9. So let's write those down. In this case, we're going to write n. So you have n equals 16 and n equals 9, right? So those are our two values that can be possible. Out of the answer choices, right, you'll see there's no 16. So therefore, right, we can cross 16 out, and 9 is going to be our answer choice, which is going to be C. So once again, I hope that made sense. If you have any questions down, please leave them, right? I'll read them through and make sure to answer them back. But I hope you guys enjoyed this video, and I'll see you next time.